So in the planning, researchers have settled on a factored representation. Factored representation means there are different modules, and these different modules are act with each other, and they are not independent. They are dependent with each other. Uh, one in which the state of the word is represented by a collection of variables. Here we have different sort of variable that we'll use, and these variable will be used to represent any state. So any state in the set of actions that we have to achieve from reaching from initial state to the final state, or the initial state or the initial position of the robot to the final position of the robot, we need to represent it, and we'll represent it with the help of, now what we have different type of logics that we have learned. We have learned the predicate logic, we have learned the propositional logic. So based on that, we'll just represent it, and we'll use some sort of variables to do that. Okay. And here we are going to use the language called PDDL, which is called Planning Domain Definition Language. So in the previous slide, you have just seen that what we are going to do in the planning system. We are going to understand domain description, action specification, and goal description, so that all these things can be represented with the help of this PDDL, which is called Planning Domain Definition Language. And with this particular PDDL, we are going to describe all those things. Here we can describe 4 things based on this PDDL, and we need to define in the searching problem. So first thing is we can describe what is my initial state with the help of PDDL. We can describe the actions that are available in the state. So what are the actions that we have in one state that we can define? The next, we can define the result of applying an action. So after applying the action, what is the result that we can define, and we can do the goal test. So all the time we can do the goal test, and we should know what is goal. Then only we can do all those things. So in the initial state, we are in the initial state. We know what is the goal state. We should know that what are the available action on the state, and when we perform any action, what is my result. So all these things can be represented with the help of PDDL, which is called Planning Domain Definition Language, and that we are going to see in this particular course, that is PDDL. And in the PDDL, there are many versions of PDDL. We are going to understand the version 1.0. And this version 1.0 is the advanced version of strips, okay, that we have just seen, right? So strips is nothing but Stanford Research Institute Planning System. It is called strips. So this is advanced version. Strips advanced version is called PDDL, and PDDL's first version we are going to see here. Now let's come to PDDL, which is called Planning Domain Description Language. Here, each state is represented as a conjunction of fluent that are ground functionless atoms. So here you understand that every state, whatever state we have, let's say we have initial state, we have intermediate state, we have goal state. So every state that we are going to represent in PDDL will be represented with the help of ground functionless atoms. It means that we have some sort of representation like this. Here we have different variables or different constant, and based on that we are going to represent one state. So here one state is defined. You can see here with the help of an example. Here it is written at truck 1 comma Melbourne, and which is conjunction at truck to Sydney. What is the meaning of that? That it says that truck 1 is at Melbourne and truck 2 is at Sydney. So this is the state. In one state, truck number 1 is in Melbourne and truck number 2 is in Sydney. So this is defining one state. Okay, this is defining one state. And these are the variables, right? So truck 1, or not the variable, you can see this is the constant. So truck 1 is there, which is there in the Melbourne, and truck 2 is there, which is there in the Sydney. So here, when I say ground functionless atom, means there will be no variable and there are all constant value. Atom means this is one atom and this is another atom. So one clause and another clause, you can understand. So these are two clauses here, and based on this action will define that this is my one state. So this is defining one state. Now let's understand something more here in PDDL. Now come to the, so what we know, that what we can do here is, first thing, we can define PDDL with the help of initial state. So first we can understand what is my initial state is. Second thing, what can I understand is set of actions that I can perform in the state, in any of the state. Third thing is, if I'll perform some action, what is my resulting state? And the next thing that we know, that it is called goal test. So all the time when I reach from one state to another state by performing the action, and that action is resulting to different state, so when I'll do that, I'll do the goal test all the time. So all these are nothing but set of actions, sorry, set of state. And we can achieve from one state, let's say we are in one state, to reach another state. Let's say this is state 1 and this is state 2. We should perform some sort of action, right? We have to perform some sort of action. And after reaching to that state might be the goal state. So we have to test it whether this state is a goal state or not, right? Or this state is a intermediate state, or whatever it is. Every state will be represented with some sort of uh, some sort of ground variable or ground actions, or with the help of propositional logic we define some actions. We define the state with some propositional logic. Okay, so every state will be defined with the help of some propositional logic, and will apply the propositional logic to define one state. Okay, and when we have the propositional logic without any variable, that is called grounded atom. Okay, or ground atom, you can see. So a set of ground atoms. Now let's understand what is action. So the actions are described by the set of actions schemas that implicitly define the action as and result as A. What is the meaning of action as? So we have some actions that is defined in each state, and this action is nothing but we have to apply some results. So we'll apply the results in a state, let's say S, and we'll apply the action A on it, and this result will give me another state. So you can see that if I am in S, if I'll apply A action, I'll reach to another state S dash. So this is how the result will be. So every action is resulting me another state. So every action is resulting me another state. So if I am in state 1, so the action will take me to another state, state 2. So the functions needed to do a problem solving search. So here, the set of actions that will perform, let's say we are in the initial state, and from the initial state we can go, if we'll perform action A, so we'll reach to, let's say, state 2. If I'll perform action B, I'll reach to state 3. Let's say if I'll perform action C, I'll reach to state let's say 4. If I'll perform action D, I'll reach to state 5, in that way. So let's assume that 5 is your goal state. So how I'll reach the goal state? So this is my plan. The plan is from state 1, I'll perform action B, and then state 3, I'll perform action D, and I'll reach the goal. So what is my plan here? The plan here is from 1, I'll perform A, and I'll reach to 3, and from 3, I'll perform B to reach my goal state 5. So this is my what set of actions. So that we have to find it out in this particular code, in this particular chapter, okay, or in this particular topic. Here it says that the set of ground, which is a variable free actions, can be represented by a single action schema. So we have some action schema. So we'll understand what do you mean by action schema and how we'll represent one action. This schema is a lifted representation. It lifts the level of reasoning from propositional logic to a restricted subset of first order logic. So here this action is not the propositional logic. Actually, it is a first order logic, it is saying. For example, here is an action schema for flying a plane from one location to another location. Here we have an action. What is that action is? The action is fly action. And in the fly action, we have some variable P from 2. It says that plane P will fly from one let's say airport to another airport, right? So the plane is flying from one airport to another airport. This is my action. So the how action will define the action with two things. One is called precondition, another is called effect. Okay. So what is the meaning of precondition? Precondition is when I want to perform this actions, I should have all these conditions satisfied. Then only I can perform the action. So that's why the precondition is written here. So let's say if I want to fly, the plane should be fly from one source to the destination. So what is the precondition? The precondition is plane should be at this source, right? Should be at this source, and P is a plane. From is nothing but the airport, and to is also an airport, right? So from is also an airport and to is also an airport. This is my precondition. The precondition says that your plane should be from in the destination, your P should be the plane, your from should be the airport, and to should be also an airport. Okay. Now all these preconditions are joined with the help of a conjunction operation. Means all these are necessary conditions that has to be satisfied, then only we can perform this action. So if my plane is not in the from airport, so definitely I cannot fly from airport, right? Let's say my plane is there in two airports, so definitely I cannot do that. I have to fly from to from, and I have to land it, and then this condition will be satisfied, then only I can perform this action. Now after performing the action, what is the effect is your result, right? So what is the effect? The effect or the result will be, it says that not at P from. What is the meaning of that? Plane is not at from airport, right? Because it has flight already. And P is at to airport. So definitely when it will fly from airport, it will go to, definitely when it will fly from airport, it will go to airport, right? So it will be at to airport. It means that let's say you have a platform, or you have an airport from, so from is your airport, and 2 is your airport, right? So these are your airports. So I am putting as a like this. So these two are your airports. Now you have a flight. Let's say you have a flight, and this particular flight is previously there in, let's say that this is your plane, right? So this is P. So P is there in from airport. So this condition is satisfied. We say that P is a plane, from is an airport, to is also an airport, and P as at which airport? From airport. Now, when I'll perform this action, what will happen? When we perform this action, this P is flying and reaching to airport, right? So right now my plane is there in this particular airport. This P is there in the airport. So what is my after effect? The after effect is P is not in from. So definitely it is not in from airport, right? It is not there. And where it is, the P is there in to where. So this is how my result is. So every action we should define the precondition and the effect. Okay, so that we have to define. The schema consists of the action name. The schema consists of the action name, a list of all the variable used in the schema. These are the list of all the variable that will used in the schema. A precondition. This is the precondition that we have to use, and effect that we have to use. So when we perform any and when we write any action in PDDL, we should have all those things with it. We have set of variables, and with the help of actions, we should have a set of preconditions, and we should have set of effects, right? And effect is nothing but your result part. So I think you understood the action part right now. Let's see some example here. So the same example of fly action that is there in the uh, previous slide, we just used here also. What it says that we have to perform an action. The action name is fly, and we have to fly plane 1 from, let's say, San Francisco airport to JF Kennedy airport. Okay, so this is my source airport, which is called San Francisco airport, and this is called GFK airport, which is your JF Kennedy airport in USA. Okay, so what is the precondition here? The precondition here is this plane P1 should be at San Francisco airport, and P1 is a plane that is San Francisco, that is SFO, which is a short of form of San Francisco airport, is an airport, and JF Kennedy airport, which is called JFK airport, is also an airport, right? So that is my precondition. If all these conditions satisfy, then I can perform this action. After performing the action, what will happen? My plane is not there in the, not anymore in the San Francisco airport, and it is there in the JF Kennedy airport. So this is how your action is written in the PDDL with the help of precondition and effect. Okay. Now, to understand the previous example that we have just written there, a set of action schemas serve as a definition of planning domain. So when we have set of actions, that set of actions are nothing but defined as the planning domain. So in the planning, when we do a planning, specify a planning to reach the goal, we should have set of actions. The specific problem within the domain is defined with the addition of an initial state and goal. So what it says that specifically at very first, when we define any problem with the domain means I should know the environment. I should know my world where I am acting. So I should have initial state that what is my initial state, and I should have the goal state, right? So that I should know. So what is my initial state and what is my goal state, I should know, along with the domain knowledge, along with the environment knowledge. What is my initial state? The initial state is the conjunction of ground atom. As with all state, the closed word assume is used, which means that any atom that are not mentioned are false. So anything that is there in the initial state, I am defining it with the help of ground atoms. Ground atoms means your variable less propositional logic or the first order logic will apply there, and we should define the initial state. In this initial state, if we do not mention anything, means that condition is false. What is my goal? Goal is just like a precondition. So a conjunction of literals, positive or negative, that may contain variables such as this: at P SFO, it means that plane is in San Francisco airport and P is a plane. So in that way, we can define the goal. Any variables are treated as existentially quantified. So this goal is to have any plane at SFO. So here, this P is nothing but existential quantifier. So we are not saying all the plane are in San Francisco airport. We are assuming that any plane is in San Francisco airport, and this any plane is a plane. Any P is a plane. So here we'll use existential quantifier, but we cannot represent existential quantifier here in PDDL. This is how we represent an existential quantifier with the variable, let's say EP. So we'll say that any P, and what is P? So P is a plane, right? So this we do not use here, we'll use this only. And we always assume that P is taken as the existential quantifier. The problem is solved when we can find a sequence of action and end in a state as that entitles the goal. So entails the goal. So what it is saying that the problem is solved. When the problem is solved, when we have set of actions, let's say action 1, action 2, action 3. So this is my set of actions. So when we have these set of actions and the result of this set of action is the goal state, right? So I have the initial state. I perform action 1, action 2, action 3, and then I'll what are the state I'll achieve? I'll reach the goal state. So in that way, I define any problem, or I can solve any problem. I can solve any problem. For example, the goal state is P is at San Francisco and P is a plane. So here what it is saying that this P is a variable here, and this plane 1 and plane 2 is nothing but the constant values here. Okay, and we can define the goal in that way, in some sort of variables, and that variable can be achieved. Let's say I have defined uh, a goal. The goal says that any plane should be at San Francisco airport, and that P should be a plane. So if I'll write this plane 1 is in San Francisco and this plane 1 is a plane, so definitely my goal will be achieved. Apart from this P, so P is taken as a variable here, and here P is taken as a ground. You can say grounded one. Grounded one means this is not a variable, this is a constant value. So if I'll do that, I say that I achieve the goal. So what I want to say is, we'll not get the exact value P which I have defined in the goal. I get the constant value here in the goal state. So this is how I can define, I can say that I have achieved the goal. Now let's understand whatever we have just learned with the help of a example. This is an example called air cargo transport, and we have some initial state here which is defined here. This is the initial state, this is the goal state, and we have some set of actions. Let's say this is action 1, this is action 2, and this is action 3, right? So we have initial state, we have the goal state, and we have set of actions. We know that how we'll define the action. Action should have the precondition and the effect. Action should have the precondition and the effect. Action should have the precondition and the effect. And action will be defined with the help of the variables. And we have some preconditions. These preconditions are defined with the help of predicate logic, which is your first order logic. And here we do not use existential quantifier. We assume that all the variables are as in the existential quantifier. Now, this particular figure shows air cargo transport problem involving loading and unloading cargo and flying it from place to place. So what is the meaning of cargo? Cargo is nothing but some sort of goods or some sort of yeah, some sort of you can say the goods or some appliances or something. Some we take it as a cargo. So cargo, we have to fly from one airport to another airport, right? And what are the actions we have? We have action of loading. We can load the cargo into the plane. We can unload, means we can unload the cargo from the plane. And what we can do is, what are the other action? We can go from one airport to another airport. So we can fly. So these are the three actions we have. So you can see the action. We have load action. We can load the cargo into the plane at a particular airport. We can unload the cargo into the from the plane at a particular airport, and we can fly the plane from airport to airport, right? So this is the action that is defined. The problem can be defined with three actions, as I told you: load, unload, and fly. The action affects two predicates. In CP means that the cargo C is inside P. It means that in CP, what is the meaning of in CP? In CP means the cargo is inside the plane. Okay. It means the cargo C is inside the plane. And at XA, what is the meaning of at XA? Here, what is the meaning of at PA? The meaning of that is this plane P is at airport A. What is the meaning of at CA? The meaning is the cargo is at airport, right? At a particular airport. So at predicate will be assumed for this X will be either the cargo or the plane, and A is nothing but your airport, right? A is nothing but, here also A is nothing but airport, here also A is nothing but airport, here P is a plane, here C is a cargo, and both are used at predicate. Note that some care must be taken to make sure that at predicate are maintained properly. So here at predicate are maintained properly, and we know how it is written. So let's understand this particular problem, and then we'll see how we can reach the goal. So this particular problem, as I told you, has the initial state, has the goal state. Let's understand what is the initial state. The initial state says that cargo C1, so we have a cargo C1 and cargo C2. So we have two cargos here. So cargo C1 is at which airport? It is in San Francisco airport. And cargo 2 is at JFK, which is JF Kennedy airport. There is a P1. P1 is a plane. Where is the plane? The plane is there in SFO. SFO means your San Francisco airport. And where is your plane to? Plane to is JF Kennedy Airport. And C1, what is C1? C1 is a cargo, C2 is also a cargo, P1 is a plane, P2 is also a plane, JFK is airport, and SFO is also an airport, right? So this is just to define this particular uh, variables. So what is my initial condition? My initial condition says that, what is my initial condition? I'll write here. Or the initial state, not the initial condition, initial state. What is my initial state? My initial state says that there are two airport. One airport is called San Francisco Airport. Another airport is called JF Kennedy Airport. So in San Francisco Airport, my cargo is there, which is C1. In JFK Airport, my cargo is there, which is called C2. In San Francisco, I have a plane, and this plane are called P1. And in JFK, I have a plane, and this plane is called P2. Right? So this is, and this C2 is not in the plane. The C2 is there in the airport. Here also C1 is not in the plane. The C1 is there in SFO, means the San Francisco Airport. This is my initial condition. What is my goal condition? So let's write down the goal state. The goal state is, I have to what? Airport, San Francisco Airport and JF Kennedy Airport. What is my goal state? Goal state should be in San Francisco Airport, C2 should be there. C2 means cargo 2 will be there. And in JFK Airport, C1 will be there. C1 will be there. I don't have to bother about the plane. Plane could be in, the plane P1 could be in SFO. The plane P1 could be in JFK. I don't have to bother about it. So about the plane, I don't have to do anything, right? But here in the initial state, I have the plane. But here we don't have to bother about where my plane is. I should bother about the cargo. Means cargo is flying from C1 to C2, sorry, JFK, and from JFK, the C2 is flying to SFO. This is my goal state. So I have defined the initial state, I have defined the goal state. Now, what are the different actions we have? First action is load. What we have to load? We have to load the cargo into the plane at an airport A. So what is my precondition? The precondition is that cargo should be there in airport A. The plane also should be there in airport A. C is a cargo, P is a plane, and A is a airport. This is my precondition. If it is there, then only I can perform the action. What is the effect? Means after performing the action, what will be? Cargo is not in the airport because cargo is in the plane. That's why the cargo is not in the airport. So not is used here. So after loading, the cargo is in the air, is in the airplane, is not in the airport. So it is in the plane, not in the airport. Next section is unload. Unloading means the cargo is unloaded from the plane at an airport A. So what is the precondition? The precondition is the cargo should be there in the plane P. The plane should be there in the airport A. C is a cargo, P is a plane, and A is a airport. Okay. Now what is the effect? The effect is when I do that, then cargo should be there in the airport. Cargo is not there in the plane. Means I have unloaded it, right? Now let's go to another function which is called fly function. P is flying from airport to airport, right? So what is the precondition? The precondition is plane should be there in from airport. P is a plane, from is an airport, and to is also an airport. What is the effect? The effect is plane is not there in from airport and plane is there in two airports, right? So when it will fly, definitely it will reach to the destination. So this is the effect. So we understood this. Now, what is our goal? A goal is to reach to fly this cargo from C1, uh, cargo C1 from San Francisco to JFK, and from JFK cargo 2 to San Francisco, right? So what are the action that I should perform? So what are the action I have? So the action will be, the first action will be, we have to load, what we have to load? Cargo 1 to plane 1 in San Francisco airport. After loading, we have to fly from San Francisco airport to JFK airport, and then we have to unload the cargo 1 from plane 1 at JF Kennedy airport. So when I perform this set of actions, so what will happen? This cargo 1 will reach the JFK airport when I perform all these three actions. After that, when I'll do load P2, means plane 2, the cargo 2 is loaded into plane 2 at JF Kennedy airport. The plane 2 is flying from JFK airport to San Francisco airport, and after that we unload the cargo 2 from plane 2 at San Francisco airport. So definitely cargo 2 is there in San Francisco airport, and this is my goal. This is my goal. So when I perform these set of actions, and this is the sequence of action, right? I cannot fly. I cannot fly without the cargo loaded, right? So this fly could not be done previous to this action. So this is the sequence of action. So this is first action, this is second action, this is third action. And you can say that this is 4 action, this is 5 action, and this is action 6. So you can see that the action 1, 2, 3 should be in sequence, and action 4, 5, 6 should be in sequence. If I am performing action 4, 5, 6 first, and then I'll perform 1, 2, 3, it is okay. When I'll perform 1, 2, 3 first, and then I'll perform 4, 5, 6, then also it is okay. So here you can see that we have not defined the time, we have just defined the set of actions that we have to do to achieve the goal, right? So when a plane when the plane flies from one airport to another airport, all the cargo inside the plane goes with it. Definitely it will go with it. In first order logic, it would be easy to quantify over all objects that are inside the plane. But in PDDL does not have the universal quantifier. So we need the different solution for that. So this is how we can do that. C1, C2 will write out down. Will not use the universal quantifier, or will not use the existential quantifier. The approach we use is to say that a piece of cargo cases to be at anywhere when it is in plane. So when it is in plane, so in the plane it will be anywhere. The cargo only become at a new airport when it is unloaded. So whenever it will be unloaded from the flight, then only the cargo will be there in the airport. That's why after unloading, we can say that the cargo is there in the airport. So at really means available for use at a given location, the following plan is the solution for the problem. So this is the solution for the problem that we have just seen, right? So this is one example how we can do the planning, Now let's see another type of example here, that is called the blocks word. In this particular example, we have the initial state or the start state, and we have the final state, which is called goal state. Okay. Let's try to understand first what is the theory that is given. So one of the most famous planning domain is known as the blocks world. This domain consists of a set of cube-shaped blocks sitting on the table. So here we have a table, and these are the blocks, and these blocks have different names. Okay, these blocks have different names. The blocks can be stacked, but only one block can fit directly on top of another. So these blocks can be stacked. Stack means we can put one block and we can put another block top of another block. So we can stack it. Okay. Stack means we can put one object onto another object. So here we have a block. So let's say we have A and C will be there in top of it. So we can do the stacking. So stacking can be done. So stack is one, we can do that in the top of another one. If the top is free, then only we can stack it. The arm can pick up only one block at a time. So there is an arm. So you can assume that we have a robotic arm. So yeah, in that way we have an arm. That arm could pick up any of the blocks at a time. So it cannot pick up a block that has another one on it. So definitely, so if we have an arm, so let's say you understand this is an arm and you assume that this is a robotic arm. So robotic arm can pick up which block? It can pick up block C and it can pick up block B, but it cannot pick up block A. Why? Because block A is top of it, it is C. So block A is not clear. That's why block A cannot be picked up. The planning problem in the blocking world, building the three block tower, this is we have to do. We have to make the 3-block tower, means we have to make a stack of 3 blocks. There is a sequence and the solution is there. So the sequence, in this sequence only we have to make the tower. So what we have to do, right? So what we have to do, the first, okay. Now to understand that, let's understand what is the initial and what is the goal, what are the action that we have. So this is my initial state, right? So how we can define the initial state? I can define the initial state like A is there in the table, right? So I can write it down on A table. What is the meaning of on? Says that A is on table, right? And I have to define for B. So where is B? B is also on the table. So on B in table. So B is also on the table. What is the condition of C? So where is C? So C is on A. C is on A. C is on A, right? So this is my initial condition. If you want to define the variable, you can define it like A is a block, B is a block, C is a block, B is clear initially, and C is clear initially. So what is clear? So here you can see that you can write it down like A is a block, B is a block, C is also a block, and B is clear means top of B there is nothing. So I can see that clear B and clear C. Clear C. So this is my initial condition. What is my goal? Goal is this. This is my goal, right? So how we can define the goal? We can define that B is on C and A is on B. So how we can write? I can write like this. On A comma B means A is on B and B is on C. So this is my goal. What are the actions we have? We have two action, move and move to table. The first action is move b comma x comma y. It means that start state, which is called your initial state, and we have the goal state. Okay. What is the starting state? The starting state is that there is a cube, three cubes, b, a, and c. B and A are on the table, and C is on A. Okay. And what is a goal? Goal should be that B is on C and A is on B. Okay. This is our goal. The goal is A is on B and B is on C. This is how we read it. A on B, B on C. This is how we read it. Now here we have the initial state, which is this, that C is on A and B is on table. So B is on table and A is also on table and C is on A, right? And we all know that A is a block, B is a block, C is a block. C is clear. It means that top of C there is nothing. B is also clear because top of B there is nothing. We have to move. We have two action. One action is move. Another action is move to table. Now, what is move? Move says that if we have a B block and it is already there in X, then it will go to Y. So to understand this, I'm just writing here how it is defined. So this action is there, move. And it says that we have B, we have X, we have Y. How we'll understand this action? This action says that there is a block B which is previously there on X and we have to move into Y. Means this is the condition. The condition is this, that X is there, top of it B is there, means B is on X and it has to move on Y. So after performing this particular move action, what should be? It should be like this. The X will be there, Y will be there, but top of it B will be there, right? So when I'll perform this action, this will be there. So what is my precondition? Precondition is this. This should be my precondition. I'll perform this action and I'll reach this effect. So you understand this. On Bx. So B is on X. Yes, B is on X. The first condition is satisfied. Clear B. B is clear, means top of B there is nothing. Clear Y, top of Y there is nothing. Block B, B is a block, definitely we know block B is a block. Y is a block, we know that. And X is not defined. X could be the table, X could be the table or could be the block. But here it says that B is not equal to X, means B is not, B is, and B and X is not same. B and Y is not same and X and Y is not same, definitely. So all the condition is satisfied here because X, B and Y is all different entities. Y is clear, B is clear, and B is top of X. So when it will satisfy all the precondition, then what is my effect? The effect will be this. Means when I perform this action, after the performing the action, it look like this. So what is this? It is the effect. On by means B is on Y. Yes, B is on Y. Clear X. X is clear. B means top of X there is nothing. Not on Bx. It means that B is not on X. Yes, it is not on X. It says that not clear Y means Y is not clear. Yes, it is there. Now this is my effect, right? So definitely if I perform this action, if I have this precondition, I have this effect. Now I think you understood. Now come to the move to table. There is another action which is called move to table, right? So what is move to table? Here if you'll see, move to table. Here we have two variable, B and X. So you understand that we have to move B into the table which was previously there on X. I understand. B, we have to move B into the table which was previously there top of X. It means that what is the precondition we have? That we have X like this, we have B like this. So this is B, this is X. B is on X. This is my precondition. The precondition is B is on X. B is clear, means top of B there is nothing. B is a block and B is not equal to X. So B is not equal to X. Now what is the effect? The effect will be when I do that. So what it will be look like? It will be look like this. There is a block X, and when I'll perform this action, this block B should be on table, right? So this is my effect that can be represented by this. B is on table. Yes, B is on table. Clear X means top of X there is nothing. And it says that B is not on X. So B is not on X, B is on table, right? So this is my effect. So I think now you understood what is this action is. What is this action is and what is this action is, okay? Now come to here in this particular problem. The problem is we have the start state and we have the goal state. We have to perform some actions so that we can reach to the goal state, okay? Now here, I'll draw all those things that we have just seen. So what is my starting state? My starting state is like this. We have blocks in this form. So what is that block is? The block is B, A, and C. So here we have B, here we have A, and here we have C. This is my initial state. What is my goal state? Goal state will be like this, right? Goal state will be like this. Now we have some actions. So we have two action. One action is move. We have two variable for move that we can put. Let's say variable 1, variable 2, variable 3. And we have another action, move to table. Here we have variable 1 and variable 2. We know what is a precondition and what is the effect of it. Move 1 and move 2. So we have two actions. This is my initial state. How will you define an initial state? You can define the initial state by this. What it says? It says that on B table. What is the meaning of that? That B is on table. What is the second condition? Second condition is A is also on table. And what is the third one? Third one is C is on A, right? C is on A. C is on A. And other condition, if you want to write, you can write it. Otherwise, it is not required. What is the other condition? Other condition is B is a block, C is block, A is also block, B is clear, and C is also clear. So that is, we doesn't have to do that. So we'll just ignore it. Now, what is my goal state? The goal state will be like this. On AB, it means that A block should be on B, and on BC, it means that B block should be on C, right? So this is my goal state. So this is my goal state. So I have to go from initial state to the goal state. So what are the action that I'll perform so that I can go? So definitely, if you'll see this particular state, so you can see that the C should be there in the table first, right? C should be there in the table. And then we have to perform like B should be top of C, and then we have to perform A should be top of B, right? So this is the action we have to perform. So the first action should be that we have to put C on the table, right? So we have to use action 2. We have to push action 2 here. So what I'll do, the first action that I'll perform from here to is move to table, which we have to move to table C, which is already there in A. So what is my state after this? After this, my state will be like this. There will be B, there will be C, there will be A. So I think this part you understood, right? Now, after doing that, to achieve this goal, what should be the next thing is that B is top of C. So B should be on top of C. So we have to perform the second move here. Second thing here is move. Move. Which we have to move? We have to move B, which was there in the table, to C. Right? We have to move B, which was there in the table, to C. Right? So all the preconditions satisfied, because C is free right now. B is on the table right now. So we'll pick up B, and B is clear. So the arm will be pick up B and put onto C. So after this particular move, what is my state look like? This is my state. Right? Now I have done halfway. What is the next is A should be there in top of B. So what is my next move? The next move will be like this. Next move will be, I have to move A, which is there in table first, into B, right? So after doing that, it will look like this. So C will be there previously, then B is there, and now I am putting A into C. Now when I'll do that, I'll see that this is my goal state, and then I'll stop. So what is my plan? What is my plan? So plan will be like this. Plan will be, the first I'll do move to table CA. Then next is move B from table to C. And then I have to do move A from table to B. Right? So this is my set of actions, and this is my plan. Set of action is nothing but the plan. Set of action is plan. So I think you understood this, that how it goes. All the time we have to see the preconditions. If preconditions satisfy, then only we can perform the action. So these are all action. The move to table, all these are actions, and these action will be performed once this precondition will be satisfied, right? So let's go to the slide again. So you see the first is move to table C comma A, then move B from table to C, and then what we can do is we can do move from table to B. So this is how my my action set of actions are, and these set of actions or sequence of action is nothing but my plan to reach the goal.